Hi, I'm Gabrielle, and this is my third video on how I study for the MCAT. And this one's going to be mostly about flashcard quiz. I'm going to go through my deck of note cards with you. But before we do that, I'm just going to tell you how things have been going since the 3 weeks that I've done my last video. So I've made a 503, a 508, and then a 505 since then. So it's kind of been steady around that 505, 504 range. So that's good, and I'm trying my best to get it up to 510, so I'll see how that goes, and I got a month to go. But without further ado, we'll get to the note card portion. How it's going to go is I'm going to say the note card and try to phrase it as a question, and then if it involves a formula, I'll write the formula down, but I'll give you a little bit of time to pause the video or think about the answer. And I'm just going to play the Jeopardy theme song for a few seconds and then pause it, and then you can do whatever you want to. Try to answer it. So, first one is, what is the difference between simple diffusion and facilitated diffusion? So, let me put the music on. And then you can just pause it if you want to, have extra time to think about it. But I'm going to stop it. Okay. So, simple diffusion and facilitated diffusion both cause a solute to go from the with its gradient from a high concentration to a low concentration. But the only difference is simple diffusion is unassisted, and facilitated diffusion involves a transmembrane protein. So the molecules actually go from a high to low concentration by going through a protein complex. So simple is unassisted, and then facilitated involves a transmembrane protein. But, okay, next one. That one was kind of from biochemistry, biology kind of thing. This one's from psychology. And what's the difference between incidence and prevalence? So incidence and prevalence. So, incidence is the number of new cases of a disease that happen over a period of time. It's usually a year, but it's just the number of new cases only. So, for example, if you have the number of new cases of diabetes type 1, it's just the new ones, not people who already had diabetes type 1. But prevalence is the number of cases overall. That includes new and old in that specific time period, which is usually also a year. So, in the year of 2005, we have so many cases of diabetes type 1, including new and old cases. So that's kind of the difference. Incidence is just new cases, prevalence is new and old over a specific time period. Okay, next one is a sociology topic. What are the 3 formal organizations in sociology? Okay. So, the 3 formal organizations are utilitarian organizations, which are when members get paid or compensated for joining that particular group. So, if I got paid to join a particular club, that would be a utilitarian organization because I'm getting compensated for my efforts. Normative organizations are when we all join together because we have we have the same moral goals or moral values. So it's kind of like your religious group. We all join together and form this group because we have the same values and beliefs. But the last type of group is coercive groups, and that's when members don't have a choice in participating in that group. And the one that kind of appears a lot on the MCAT, or at least my practice does, have been prisons, because prisoners don't have actually a choice in joining their group and being prisoners. They're kind of forced to do it, so that's a coercive organization. Okay. Next one is biochemistry, and just the definition of a word. What is the definition of a conjugated protein? Oh, there it goes again. Okay. A conjugated protein is a protein that contains a prosthetic group, and that's a group that doesn't consist of amino acids. Usually prosthetic groups are divided into coenzymes and cofactors. Cofactors are your inorganic compounds like metal ions, and coenzymes are your organic factors that a protein needs to function. So an example of a conjugated protein would be hemoglobin, because it can't function without having its iron subunits, and that's a prosthetic group. Okay. At standard temperature and pressure, 1 mole of an ideal gas occupies a volume of blank liters. Okay, so it actually, 1 mole of gas at standard temperature occupies a volume of 22.4 liters, which is your standard molar volume. And I'll probably like round it down at 22 liters because the math can be kind of iffy when you're doing decimal places. So roughly 22 liters. Okay. Next one is the difference between anterograde amnesia and retrograde amnesia, and it's kind of a psychology concept. Okay, so anterograde amnesia is you have an inability to form long-term memories after a brain injury. So you get into a car accident and you can't form new long-term memories, and that's anterograde amnesia. Retrograde amnesia is when you can't remember things prior to that brain injury. So you get in a car accident and you can't remember what happened before you got into the car accident. And those are kind of things that just vocabulary words to know in the MCAT. Let's see. This next one kind of deals with genetics. So let's do this one. What are the 5 assumptions for Hardy-Weinberg law? Oops, I put the music on the wrong time. What are the 5 assumptions for Hardy-Weinberg law? Okay, 5 assumptions. Okay, so your population must be large. It must not have any mutations, must have no natural selection, no immigration or emigration, and random mating must be in effect. So that's your 5 things. Large population, random mating, no immigration or emigration, no mutation, and no natural selection. Okay. Let me kind of let me see how we're doing on time. 7 minutes. Okay, so we'll do like 2 or 3 more and then call it quits. So this next one kind of involves me drawing something, but the Line-Weaver-Burke plot, which is a very important concept for biochemistry and enzyme function. First of all, what kind of plot is it? Is it a curved plot, sigmoidal, or linear plot? Then what does the y and x intercepts represent, and what does the slope represent? So let me put the music on, and I'll draw it out for you. Sorry, it kind of takes a while to do all this. So, here is your answer that you should have come up with. So over here, that's supposed to be a line, so it's supposed to be linear, but I can't really draw a straight line. It's supposed to be linear, and then your y-axis on a Line-Weaver-Burke plot is 1 over the velocity, and then your x-axis should be 1 over the substrate concentration. So those are your y and x axes. And then your y-intercept, which is right here, has this formula, 1 over v max. And then your x-intercept, which is right here, has the formula -1 over km. Don't forget your negative sign, because you have to make it a positive number. And then your slope of this line is km over the Vmax. And remember, km is your Michaelis-Menten constant, and then Vmax is your maximum velocity. So that's the whole plot. And let's just do one more quick one. Okay, so this is kind of chemistry. So what's the difference between the Aufbau principle, Hund's rule, and the Pauli exclusion principle? Okay, so Aufbau's principle says that you must fill electrons in the lowest energy orbital before you fill electrons into higher energy orbitals. So like, for example, your principal quantum number, or n equals 1 shell, should be filled before your n equals 2 shell. So yeah, electrons fill lowest energy orbitals first. Hund's rule says that every orbital must be half full before it can become all the way full. So if I have 3 electrons, I would put them, that's kind of awkward. If I had 3 electrons, I would put them all singly occupied before I paired them. So I would go up, 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 and then go back and pair them. And then it also states that all your singly occupied orbitals must face in the same direction. So I can't, this one has to be facing the same direction as that one. I can't just randomly switch this one around. So that's like Hund's rule. And the Pauli exclusion principle is kind of the vaguest one, the one that people like mess up the most, but it's kind of actually pretty simple. It states that no 2 electrons can have all the 4 same quantum numbers. So like for 2 electrons, they can't have all 4 quantum numbers in this be the same. So basically what that means is they have to occupy different spins. So if one's going up, the other one has to go down, and that kind of like makes sure that you don't have all the same quantum numbers. Okay, so I think that's where I'm gonna end it for this time, and then if you want to see it again or like have me finish the rest of this deck of note cards, I can make another video, but until then, goodbye.